Welcome to the channel MNU Tricks. Today we are going to discuss a very important topic which is about sample size calculation for unknown population. When we face this problem, when there is no exact count of population or sampling frame unavailable, what does it mean? It means that when we are going to sample a population, that the population is uncountable or infinite. For instance, we are interested to know the uh, exact prevalence of drug addictors, and there is no data available. So that is the infinite population. There are a lot of examples of this kind of research, and we do face this problem normally when we are going to conduct any research study. So unknown means the population which is large or infinite, already we discussed. So which sampling technique is recommended in this case? Convenient or purposive sampling in case of non-probability sampling. And in case of probability sampling, use any of the sampling technique, but recommended technique is cluster random sampling. Again, why cluster is recommended here? Because in case of large population or infinite population, cluster is more convenient than any other sampling technique. So in the next slide, we are going to discuss that which formula is recommended in this case. As the target population for study is unknown or the population is very large. So for large population, Cochron in 1963 developed an equation to yield a representative sample. What does this equation means? In this equation, n, usually we use n in sample size calculation formulas. If you have seen a number of formulas that includes n, those formulas are for the finite population or when we have the population available. In this case, as the population is unknown, so n is excluded. Here we are using only the z. What is z? Z is basically the abscissa of normal curve. And if you are using the 95% confidence interval, then the z value, critical value is 1.96. P is the proportion of success. It's also called the prevalence factor. Q is the 1 minus P, or we can say that the proportion of failure. And E is the margin of error. We have tried to explain this formula within live example. Here we have taken an example where we're using the 95% confidence interval and 5% margin of error and 0.85 the prevalence factor. When we use these in computation section, you can see that when we put all these values in the formula given above, then the sample size is estimated, which is equal to 196. So now we are going to check this calculation, this computation in the Excel where we have developed this formula. So here is the Excel calculation sheet. You can develop this sheet and this will be very helpful for your future calculation. We have taken the example, we have discussed the example, which is where we have set the P as 0.85. So we are going to set 0.85 the prevalence factor. Okay, so when there is P is equal to 0.85, Q is 0.15, E square is basically the margin of error. So 2 times the margin of error is 0.5. When we multiply that square P and Q, we have this value, and when we divide this with the margin of error, then we get 196. You can see here is the multiplication and here is the division. What we have divided, in 7 divided by E6. E7 is the Z square P and Q, and E6 is the margin of error square. So the main thing which works, the main point which is essential for this kind of formula is the prevalence factor or the population proportion. What is the myth behind the population proportion is, if we don't know the population proportion, so usually it is recommended to use 50% or 0.5. So let's say when we put 0.5 in P, then what is the result? 0.50. So when we put 0.50, then then the sample size is 384. This is statistically significant sample size at 5% confidence level. So P is when the P is unknown, either to use 50%, and if the P is known, then you have to use the exact value. So P can also be calculated using a pilot test. For example, if you are studying, you are discussing, you are going to study a certain topic. So you can carry out a pilot study on that topic, collecting a few sample, and based on that sample, you can calculate your prevalence factor. That what proportion of population is basically affected by your treatment, right? So here we have taken an example that again the P can also be obtained from the national statistics, the studies which have been from the studies which are conducted previously on the topic which you are interested. Or the national statistics can also be used. For example, infant mortality. So state results state that is 5%. So if your target study is infant mortality, so what proportion of infants die? So it's the nation statistics says that 5%. Okay, so just 810. So in case if there is a 5% prevalence factor, then the sample size is 73. So you can see that the sample size increases or decreases based on the prevalence factor. So the sample size is also affected by the margin of error as well. Here we have used the margin of error which is 0.05. If your margin of error is 0.06, then the sample size decreases. Means if you're increasing the margin of error, then the sample size shrinks, right? So if you're decreasing the margin of error, then the sample size must increase. Of course, is 4. Look, when it's 5, it was just 70, and when it is 4, then it's 11114. What does it mean? The small margin of error means more chances of precision. So more chances, the accurate results is only possible when you have a large sample size. With small sample size, usually we compromise the precision. So this was all about the sample size calculation in case of unknown population. I hope I hope you learned how to calculate the sample size in case of unknown population. If you find this video interesting and informative, please share and subscribe the channel and press the bell icon so that our new updates will arrive you. Thank you.